For more than 140 years, ThinkAesculap has stood for high-quality surgical instruments and innovative solutions for surgery. With more than 20,000 products, ThinkAesculap offers an extensive and continuously expanding product range. An ongoing partnership with medical practitioners and clinicians allows the B. Braun Esculap division to develop and manufacture innovative products for all surgical disciplines. Based on increasing customer demands, ThinkAesculap faces the challenge of continuously optimizing its already high-quality product offerings.
I've been in surgery for more than 38 years now. This means I have worked nearly every day in the operating theater. Within this time, one certainly receives a lot of experience regarding technique and also the required instruments. Here in Germany, we have an outstanding tradition, unparalleled throughout the world as far as manufacturing excellent surgical instruments is concerned. And ThinkAesculap is at the very forefront. Some of the instruments we are using here today, we've had in use for the past 22 years. The quality and precision of ThinkAesculap instruments don't occur by chance. The performance requirements for new instruments are clearly defined at the onset of the development process. To implement and control this level of quality worldwide, ThinkAesculap creates a comprehensive and detailed quality standard for every single instrument. This quality standard contains manufacturing guidelines ranging from raw material specifications to product surface and performance characteristics. In addition, a detailed inspection plan for each manufacturing step is implemented, using a three-dimensional master pattern to ensure consistency. Our management system is certified according to different international requirements, and our products are produced according to international quality standards. However, the quality doesn't stop there, as we have also implemented our own stringent sets of quality guidelines, which in many cases incorporate tighter tolerances than those permitted by the DIN ISO standards. This higher internal ThinkAesculap quality standard ensures the exact reproducibility of instruments of identical dimensions, precision, and quality. This reproducibility begins with construction drawings along with the gold-plated master samples which are catalogued and labeled in Tuttlingen, Germany. These master samples are then issued to each ThinkAesculap manufacturing facility as the instrument's gold standard for quality. Before the golden master samples can be put to use, the first criteria of our quality standard must be met, choosing the right material. Whereas the DIN ISO standards permit the use of up to 5 different qualities of steel for one instrument, ThinkAesculap defines just one single alloy for each instrument. To make sure this is implemented, all raw material purchasing is centrally controlled in Tuttlingen, Germany. From here, the steel is distributed to the global manufacturing network once it has met the stringent ThinkAesculap quality criteria. This means that even if it comes with the highest quality specifications, each batch of raw materials arriving in Tuttlingen undergoes exhaustive testing in the ThinkAesculap laboratory. Shape and dimensions, chemical composition, mechanical properties, material structure, and many other criteria are evaluated. Only the best possible raw materials are used by ThinkAesculap, ensuring optimum hardness, stability and wear, and corrosion resistance. When the steel passes all testing, it is released and embarks upon its journey to ThinkAesculap manufacturing locations all over the world. Upon arrival at a manufacturing site, the raw material is given its basic instrument shape in the Esculap forge. For us, operating our own forge and furthermore making all our own tooling is another important aspect of quality. In-house production of tooling and dies, whether by computer-controlled precision or skilled manual craftsmanship, ensures the accuracy of the forged raw parts. This very early stage in production provides the foundation for the high reproducibility of our Esculap instruments. The breadth of the product range is reflected in the several thousand forging dies Esculap produces. The raw part is already taking on the appearance of an instrument, but still has up to 60 more manufacturing processes to go through before it is finished. The first of these is to inspect the quality of the forged component. With the quality inspection successfully completed, the forged parts receive further processing on modern milling machines. This is going to be an atraumatic occlusion clamp. Here, for instance, we're milling in this tiny serration. If you look at it, the teeth are only 1/10 of a millimeter high, and all the teeth are completely identical in shape, each one just like the next. That's important for the clamp to be able to close a blood vessel safely and precisely without damaging it. Everything has to fit together with absolute precision. A particularly fine example of precision milling can be seen in the production of micro scissors. The extremely delicate and complex handpiece and working end are milled from one solid section of steel or titanium and then assembled to form a high-precision instrument. Despite the accurate technology, even this manufacturing operation is followed by a quality inspection using the drawing and, depending upon the process that has been completed, the gold master sample as well. The gold master sample is an essential component in Made by Esculap quality and therefore an absolutely basic tool for all surgical instrument makers. Painstaking manual craftsmanship is required for attaining the stringent Esculap standard. The education given to our craftsmen goes much further than basic subject knowledge and manual skills. When I started my training at Esculap 35 years ago, my older colleagues told me I had to give the instrument its soul. I couldn't make any sense of that then, but over the years I have come to understand what they meant. Today I see it slowly taking shape and becoming better and better, and each time you handle it, you give it its own individual essence, like a work of art. Now I'm passing my knowledge and experience on to my younger colleagues, to the next generation, so to speak. All Esculap workers know that the precision, functionality and handling of the surgical instruments they produce have an influence on surgical operations that frequently save lives. And they share the sense of responsibility this brings. So it's not surprising that manual craftsmanship and devotion to detail result in the creation of very special instruments. Once the surgical instrument maker is convinced of the quality and functionality of an instrument, in accordance with the high Esculap standard, it is sent to the heat treatment department, where it is hardened to a precisely defined strength. What might at first sound like a simple standard procedure actually requires a great deal of experience and the application of modern technology. Hardening is not that simple. It's an important and complicated process because hardening alters the structure of the material so as to give each instrument the properties it will need. Flexibility, elasticity, resistance against wear and corrosion, and so on, and also make sure it keeps them long term. The instrument must be equally hard all over, and of course all instruments of the same type must have the same hardness values. To achieve this, we work with state-of-the-art computer-controlled vacuum hardening equipment, in which we can define the heating and quenching processes extremely precisely. Using this special technique allows us to create instruments with optimal functionality. For example, an occlusion clamp has exactly the right amount of elasticity to enable the surgeon to feel when a vessel has been sufficiently closed. But functionality isn't only determined by the feel of the instrument. The instrument must also have an immaculate resistant surface. Manual grinding and polishing, vibratory grinding and electro-polishing ensure that even the tiniest irregularities are removed from the entire instrument surface, resulting in an extremely homogeneous, smoothly polished surface. It is then given a non-reflective matte surface to make it perfect for use in the operating room. In our passivation plant, the instruments receive their natural protective layer, which will remain effective for many years. A chemical process improves the resistance of the instrument surface, protecting it against aggressive cleaning agents and disinfectants, as well as corrosion. Now, the instruments are almost finished. But before they can be put to many years of use by the surgeon, they must undergo one last inspection check. The instruments are examined once again in accordance with the strict ThinkAesculap quality criteria, and their function is checked in a large variety of tests. Each detail is carefully assessed and checked against the gold standard for the last time. The final inspection staff live and breathe the ThinkAesculap philosophy just as much as their colleagues in manufacturing, research and development, marketing and sales. Only when a product meets the exacting made by ThinkAesculap standards down to the last detail will it receive its seal of quality, the snake staff with the crown, and find its way to the end user. Variety and pattern consistency, long life and economic efficiency, rational further development and innovation, function and precision. This is what more than 8,000 ThinkAesculap employees are committed to every day, all over the world. Quality without compromise. Quality made by ThinkAesculap.